parallel. If the current source is connected in series, the value of the current source must be the same. I think you understand about Ohm's law, right?
Yeah.
Ohm's law, what is the formula of Ohm's law?
Most I remember is V equals to IR.
Okay. V equal to IR. Okay, can you understand nodes?
Not quite.
Node. Okay, branch is a single element. Okay. Each path contain an element is considered as a branch. Node is the point of connection between two or more branches. Okay, so this is a branch because it has one element. This is node. Okay, it is connection between two or more branches. So this, how many branches here? 3, right?
Yes, three branches.
So, at the middle, this is node. Loop is a closed path in a circle. Okay. Basically, this is a node. Okay, never mind. So if we look at this picture, there is how many nodes? 3 nodes. Okay. Actually, this is one node. This is also a node. This node. Okay. All the dotted, the red dotted is node. Okay, but we can jump. We can jump this node to be one node. Okay, so that so this one is B, it is B. Okay, same goes for the bottom nodes. Okay, we can jump them together and make it a node only. Okay, so one node, 2 nodes, and 3 nodes here. So only 3 nodes. Okay, understand?
Understood.
Understood. Okay. Okay, in a series path, okay, only one current flows through the path. So let's say we have R1 here and R2. V1 is the voltage drop across R1, V2 is the voltage drop across R2. The current flows through R1 is the same as the current flows through R2 because series path. 2 or more elements are in series and carry the same current if they exclusively share a single node. 2 or more elements are in parallel and have the same voltage if they connected to the same 2 nodes. Okay, so V1, V2, and V3 represent the voltage drop across, let's say R1 here, R2 here, and R3 here. So the voltage drop across the 3 resistors is the same. Why? Because the connection is in parallel. Okay, parallel connection is happen when the 2 or more resistors are connected at both 2 ends. Okay, this one end and the other end. Okay, connected at both ends. Okay, so they have the same voltage. Okay, Kirchoff's law. we have two types of Kirchoff's law, Kirchoff current law and Kirchoff voltage law. Okay, so Kirchoff current law deal with the flow of current as its name. Kirchoff voltage law deals with the voltage drop in a loop. Okay, so this is Kirchoff law. Current entering a node is equal to current leaving the node, or summation of current entering a node is equal to 0. Any question about this slide? Any question? Can understand?
From my understand is I1 plus I3. It means it's entering the
Okay.
middle node.
Okay, so up to you. You may assume current enter is positive or current leaving the node is positive. Up to you. Okay. If you assume that current enter the node is positive, then current leaving the node is negative. If you assume the other way around, so yes, you can. If you assume current entering the node is negative, so current leaving the node is positive. So now in this equation, current entering the node is assumed to be positive. Okay, so positive I1 plus I3 plus I4 minus I2 minus I5 is equal to 0, or you may also write current enter is equal to current leaving the node. Okay, so this left side is current enter the node I1, I3 and I4 is equal to current leaving the node I2 plus I5. Any question?
Oh, good so far.
Okay. Okay, so we can find I here by applying Kirchoff current law. Okay, same goes for this. IT or I total here is leaving the node. The node is here. This is considered as one node. Okay, so I1 enter the node, I2 leave the node, I3 enter the node. So write the equation of KCL. This is KCL equation. Okay, this is KCL equation. IT is equal to I1 plus I3 minus I2. Any question?
Madam, the slide is gone.
Okay. So how about this slide? Can I understand?
The slide is not showing on the MS screen.
Not showing on the screen. Really?
Yeah.
Lah. Apa tak cakap dari tadi?
Dia baru jadi tuh.
Yeah. Okay. Just now, my screen is shown on your screen, right?
Okay, now it shows.
Tadi, from the beginning, nampak my slide or not?
From the beginning nampak.
Okay.
First
Tadi dia
ada slide.
tiba-tiba tu.
Okay, and then it disappear, right? Okay.
Yeah.
So now, can I understand this example? You watched the video, right? You watched the video before, right?
Yeah, just up to nodal only. I haven't reached this part yet.
Up to nodal. So nodal is far away from this line. Okay, so we start with Ohm's law and then Kirchoff's law, followed by series parallel circuit, voltage divider, current divider, and then nodal analysis. Okay.
Okay.
Can I understand this, Abdul Wafi? The slides are lag. Okay, now we are at practice problem 2.7. Can you understand this example? Because I have explained in my video. No need to explain it again, right?
It's all good. It's all good.
Sorry? No need to explain, right? Can I understand?
Yep.
Okay,
Just need
so
to do a few more.
if you can understand, so never mind, we proceed. Okay, but okay, we have two types of Kirchoff law, Kirchoff voltage law and Kirchoff current law. Kirchoff voltage law deals with the summation of voltage in a closed loop. Okay, so in KVL, summation of voltage drop is equal to summation of voltage supply. So in this circuit, voltage supply is V1 and V4. Voltage drop is V2, V3 and V5. Okay. So when we do KCL equation, you may start at any element. Okay. You may start at V2, V3, up to you. Okay. How to take the positive and negative sign of the voltage drop? Please be consistent. If you start with the first sign, okay, meaning that positive V2 plus V3 minus V4 plus V5 minus V1 equal to 0. If you want to start with negative sign of the element of the voltage drop, so second or the first? The second, right? Okay, if you want to start the equation with the second sign, so it will be minus V2 minus V3 plus V4 minus V5 plus V1 is equal to 0. Okay, can I understand?
Yes.
Okay, so I think you can, I have explained in my video, so hopefully you watch the video and can understand. So VAB is the terminal voltage that we want to find. VAB is equal to the summation of the voltage source V1, V2 and V3, but you have to consider the negative and positive sign of each voltage source. Okay, so Vs here is equal to V1 plus V2 minus V3. Why minus V3? Because V3 is, the sign of V3 is in the opposite way of VAB. VAB, okay, the sign of VAB is same as V1 and V2, right? Okay, so but V3, the sign is in the opposite way, so minus V3. Or you may write the KVL equation, depends on the sign that I have mentioned to you just now. Let's say, okay, we start with VAB. VAB is here. Minus is the first sign. Let's say we start with the first sign. I mean, we use the first sign, so you must be consistent to use the first sign for all elements. So minus VAB plus V1, okay, plus V2 and minus V3. Or you may also use the second sign. The second sign for VAB is positive. Okay, so always assume the current to flow clockwise. Okay, clockwise. So let's say we use positive, the second sign. So positive VAB minus V1 minus V2 plus V3 is equal to 0. The answer will be the same. Okay, I hope you can understand this because I have explained in my video. You must watch the video, otherwise you can understand. Okay, now this is not in my video, but I just added today. Okay, and I have posted in Microsoft Teams. Okay, this one is the, okay, see, a few seconds ago I just update the latest one in Microsoft Teams. So far so good.
Yes,
Yes,
doctor.
doctor. Yes.
Okay, this is tutorial to number 10. Okay, calculate V and IS in the circuit. V is here. It is the voltage drop across 12 ohm. IX is the current flows through this element. Okay, just imagine this is a resistor, same as this. This is a resistor. The voltage drop across this resistor is 8 volts. The voltage drop across this resistor is 2 volts. We have voltage source here, and this is dependent voltage source. It is current control voltage source. Okay, how to find V? V is here, so we are given voltage source and the value of voltage drop here. So what should we do? We just apply KVL in this loop to find V. Okay, remember KVL deals with the summation of voltage in a loop. Okay, so now I use the second sign. Okay, the second sign of this element in this loop. So let's say I start with the voltage here. So minus V minus 2 plus 12 equal to 0. So V is equal to 10 volt. Okay, V is equal to 10 volts. Please bear in your mind that when current flows through the element, the voltage drop across the element must be positive first and then negative. Okay, always assume that current flows in clockwise. Okay, and then the voltage drop across the resistor is usually positive first and negative first. Current enter this terminal. Okay, so the first terminal of the voltage drop is positive and then negative. Okay, but sometimes question can change the terminal of the voltage drop. It can be negative here and positive here. So the answer will be you should put negative in your answer. It depends on the question. Okay, so any question up to here? How to find the V? Can I understand?
Yes, doctor.
Yes, doctor.
Yes.
Okay, and then now we want to find IX. IX is the current flows through here. Okay, so when the current IX flows through this resistor, the voltage drop will be positive here and then negative here. Okay, so the voltage here is 2 volt, positive and negative. So we apply KVL in this loop. Okay, so I use the second sign. The second sign, this is the first, this is the second sign. So minus A and then minus 3IX and then plus 2 equal to 0. Okay, so the value in this equation, KVL equation, is in unit voltage because it is KVL. All the value in the equation of KVL is in voltage unit. So minus 8, so you don't need to put V because you might be confused. You may think that it is a variable. Okay, actually it is unit. So minus A equals 0. So 3ix equal to minus cix equal to minus 2m. Don't forget to put the unit at the final answer. Can understand?
Yes.
I understand so far.
Okay, so this is another example from tutorial 2 number 11. We are given a circuit from determine V0. Okay, so V0 is located here. Okay, imagine that you take a multimeter or voltmeter. You tap the positive probe. Okay, at this point, and the other probe at this point, because you want to measure the voltage, the summation of voltage. Okay, that involve 9 volt and 6 ohm, or that V0 is also equal to the voltage at the right side. Okay, it is the summation, or it involves the voltage of of 2 ohm, or let's say I name it as V2 ohm here. This is V of 6 ohm. Okay, so V0 is involve V of 2 and this voltage source. Okay, so when you see this type of question, V0 is the same if you calculate at the right side or at the left side. This is the right side, this is the left side. Okay, so depends on the question. Please choose the easiest one, either to calculate or to analyze at the right side or to analyze at the left side. In this example, it is seems like if we analyze at left side, okay, like this. Okay, let's say we analyze at right side. Okay, this is right side, the black one. So let's say we start at V0. Okay, I start with V0, the first sign. Okay, so minus V0 plus V of 2 ohm here. Okay, what is the V of 2 ohm? V is equal to IR. Okay, so in the bracket is I, this is R, and then plus 3. Okay, so equal to 4.5 volt. Okay, this equation can be solved only when we find the current first. Okay, so we start here. Okay, actually we start here. Okay, so if you want to analyze at the right side, so you have to find the current first. Okay, in this condition, I found the left side first. Okay, and then I found the current. If you want to start with the right side, if you start with right side, so you have to find the current as well. So this is the left side, left. This is left. Okay, the right one. So let me start with the second sign, V0. Okay, so minus V0 plus 9 and minus, okay, minus 6I. Okay, this is the voltage. V is equal to IR. It is equal to 0. So we have two unknown here, V0 and I. So what is I? So we apply KVL. Minus 9. Okay, this is, okay, in this equation, this is the whole loop. Okay, the big loop. This equation is for the big loop. Okay, so minus 9. Let's start with 9 volt. I use the first sign, so minus 9 plus, okay, I just add 6 and 2 become 8 and then multiply with current. Okay. So 8I is the voltage, the summation of voltage drop across 6 ohm and 2 ohm. I just add it together, multiply with I because they share the same current. Okay, and then plus 3 and then no more equal to 0 and I is equal to this. And then we substitute I in the first equation, okay, minus 6 times 0.75 equal to 0 and we get V0 is equal to 4.5 volt. Okay, now we want to prove our V0, it must be the same as the right side calculation. Okay, this is the right side calculation. Let's start with the first sign. So minus V0 plus 2 in the bracket current. Current is this plus 3 and we get the same value of V0. Can I understand?
Doktor,
Yes.
kenapa jalan kerja untuk left yang daripada right?
Lagi sekali. Apa dia? Apa dia Nazatul?
Kenapa jalan kerja yang left tu lagi panjang daripada right?
Because at the right side we have found the current in the left side, so we just use the current. If you start with the right side and then you have to find the current like this like this. Okay, you have to find the current and then you apply the current value in your equation. Kenapa V0 dua-dua sama? Yes, V0 is the same because as I mentioned just now, imagine that you connect two voltage source of 9 and 3 volt and then you take two resistors 6 ohm and 2 ohm, you connect them together, okay, and then you take a multimeter or a voltmeter, okay, and then you take the positive probe to here, the negative probe here. Have you seen multimeter or voltmeter? Have you used the multimeter and voltmeter?
Yes.
Yes, can. Okay, so multimeter or voltmeter, we have two probes, right? Positive and negative, right? So now we want to measure the voltage at the middle of the circuit. Okay, so we put the positive probe here at this point, the negative probe at the ground at here. Okay, so the reading of that value is 4.5. Okay, 4.5 is it involves 6 ohm and 9 volt, or it is equal to the summation. When I mention summation, it's not necessarily A plus B. It may be A plus minus B, okay? So that V0 also is equal to the summation of the voltage of 2 ohm and 3 volt. Okay? Any question? Can you understand? Okay.
I think I kind of understand.
Cannot. Why?
I think I kind of understand. From understanding here is that if you want to find the left loop here, we need to use the minus V naught plus 9 minus 6I, right? The ampere. But because we want to find the ampere, we have to combine the whole circuit in an attempt to find the ampere.
Yes. Yes, because the current is, okay, this is a single loop, okay? This is series circuit.
Okay.
Okay, so current is the same along the path. Current is the same. Current flows through 6 ohm is the same flows through 2 ohm. Okay, current is the same along the path. Okay, V naught. V naught is we should find where is the V naught located. Okay, now V naught located at the middle. Okay, so so you can just you can do analysis right side or the left side. Depends on which one is easier. Okay, if we look at the next slide, if you look at this slide, VAB is located here. Okay, but now you can think which one you want to do the analysis, at the right side or at the left side. Okay, you may think that if you do the analysis at the right side, it will be more easy. It will be easier because it only involves two elements here, 5 ohm and 8 volts. And then you think that it will be more difficult if you analyze at the left side because it involves three elements. Okay, two voltage source and a resistor. Okay, so that's why I mentioned that up to you which part you want to analyze, or you may want to try both and then you just verify your answer. The right side must be the same as the left side. Kita kena kira both side. Okay, you just calculate at either one. Okay, right side or left side. Okay, but in my slide I show both side because I want to show that it is proven. The right side is same as the left side. Right side kita kena bahagi ke kita dapat kesimpulan 2i per 8i. Okay, now if we start with the right side. Okay, the right side is here. So now we have to find the current first. Okay, minus V naught minus plus 2i. It will be 2i here. Okay, this is 2i. This is 2i. Okay, so I is here plus 3 and then we have to find the current. How to find the current? This is the way to find the current, and then we get the current 0.75. We substitute this value into this equation and then we will get 4.5. Always consider negative dulu. No, up to you. You may start with positive. Up to you. You may start with the first sign or the negative sign. I always like to take to start with minus V naught because at the end it is simpler to do apa ni? To solve the equation. Okay, up to you. Okay, so let's say at the right side, this is the right side, you want to start with the second sign. This is the first sign, okay, because the current will flow like this and then we meet this is the first sign, we meet the negative of V naught first and then positive. Let's say you want to use the second sign, it will be positive V naught minus 2i minus 3. Okay, the sign will be opposite, but you will get the final answer will be the same. Depends nak consider, yes, so the first or the second sign up to you because this is equation. If you choose the first sign, so you must be consistent in your equation. Any question? Does ini can you understand? Yes, okay. Any other question? If no, we proceed to the next slide.
Yeah.
No?
Yeah, it's all good for now.
Sorry?
Doktor,
Hmm.
dengar tak?
Yeah. Yes. Who's speaking? Anyone want to ask? Anyone want to ask? No? No question? If no question, we go to the next slide. This is tutorial 2, number 12. Okay. Find I and VAB, and this is the answer. This is current, this is the voltage. I is the current flows through the circuit. VAB is...
Saya Nasrin.
Nasrin? Yes? Want to ask?
Boleh tak kalau 3 positif previous slide.
Okay.
Kalau positif 3 tolak 9.
Kejap. Positive 3. This slide or this slide, okay?
Yes,
Positive.
yes.
Okay, positive 3.
Positif 3 minus 9
Okay.
plus 8i.
Plus
Boleh
8. Okay. You want to find what?
Find the I first.
Okay, you want to find I. Okay, and then repeat your equation.
Oh, I understand. So okay. I just silap baca. Sorry,
Okay.
doktor.
Okay, never mind. Okay, so this is the next slide. We find I. Okay, so how to find I? We must apply KVL at the whole loop. Okay, because current flows through current is the same in the loop. So we apply KVL in the whole loop. Okay. So let's start with this voltage source. I start with the first sign, so minus 30 plus, okay, plus. I just add 5, 3, become 8, so 8I here, okay. And then how about the voltage source? Just now we start with the first sign, right? So minus 10 and plus 8 equal to 0, okay. I just combine all the voltage source. Okay, this is voltage source, and this is voltage source, and then the rest is the voltage drop across resistors. Okay, so 5 plus 3 multiply with I. Okay, because V is equal to I R. Okay, this is the shortcut. Okay, you may write one by one. Okay, how to write one by one? Okay, so KVL minus 30 plus. Okay, this will be plus and minus. This will be plus and minus. Okay. So I start with the first sign. So minus 30 plus 3i minus 10 here, and then plus 5i, and then plus a equal to 0. Okay, so this is the real equation. Okay, I just make it short like this. Okay, can accept my my style? Can understand?
Yes, doctor.
Okay, so we get current equal to 4 amps, and then we want to find VA, VAB. VAB is step here, so let's use the right side, okay? Because it involves fewer elements, okay? So I start with VAB. You may start with V of 5. You may start with 8 volt. Up to you. I start with VAB. I use the first sign. Okay, So minus VAB and then plus 5 multiply with the current plus A equal to 0. So VAB is equal to 28. VAB is equal to 28. Now we want to verify our answer. Okay, this is not compulsory. I just want to show you that the right side calculation is equal to the left side. So this is the left side. Let's start with VAB. Okay, VAB. I use the second sign. Okay, minus VAB plus 30, and then plus 10 here, and then minus 3 multiply with current. Okay, so VAB is equal to 28. Any question? Any question?
Doktor,
No.
dia memang kena equal to 0
Sorry?
Dia memang kena equal to 0 ke?
Yes, this is equation. Okay, this is KVL equation. KVL equation states that the summation of voltage drop and voltage supply in a closed loop circuit is equal to 0. Okay. Same goes for KCL. KCL states that the summation of currents entering a node is equal to 0. Okay. Okay, this is KCL. The algebraic sum of currents entering a node is equal to 0. Okay, but if the current leave the node, so we put it negative. Okay, just like that. Or the current enter equal current leaving the node. Okay, in KVL, it involves with the voltage in a loop. Okay, the summation algebraic sum of all voltages around a closed loop path is 0. Okay, equal to 0. Or we can write like this: sum of voltage drop equal to sum of voltage supply. Bila kita kena guna CL and bila? Okay, if we want to find the voltage in a loop, so we use KVL. Okay. If we want to find current, okay, current, because current involved with branch, involved with node. Okay, like this. If you want to find current, so we use KCL. Current deals with summation of current at a node. Sum of voltage supply equal to sum of voltage drop for each element. Yes. Okay, so it is proven VAB at the right side is equal to VAB at the left side. Okay. So which one is easier to analyze, at the right side or at the left side?
The right.
The right side,
Right side is better.
because a fewer elements, right? Okay, so in this example, actually the first step is to find the current. Okay, we find the current first because we deal with the whole loop, and then the left side calculation is only this. Okay, and this is the equation for right side. Okay. So why I write like this? I start with the equation and then I find the current, because we go to the keyword of the equation. Question asks you to find V naught. Where is V naught? V naught is at the middle. It may be the right. You may analyze at the right side or at the left side. Okay, then let's say we start with the left side. Kanan kiri. The left side. So minus we know plus 9 minus is I equals. So then we have to find the current. That's the step. Okay, that's the step. Okay, so we should focus on what we should find. Okay, please do not follow exactly. Please do not follow the step exactly like this. You go to the keyword. What you have to find? You find something based on the need. Okay, either you need to find it or not. If you don't need to find it, so no need to find it. Do not follow step by step. You have to know what you have to find. Okay, so same as this. Because the question here find I, so it is clearly state that you have to find I. How to find I? So that's why I start with KVL to find the current. Okay, but it is clearly shown here that the step for the right side and the left side is the same. Okay, you just write the KVL equation and then you substitute the current into the equation. This is the next example question, tutorial 2 number 13. Okay, find Vx in the circle of following figure. So we have to find Vx. Do we need to find current? Find the current if we need to find the current. Masih tak boleh nak bezakan circuit tu nak KVL ke KCL. Okay. Okay. So up to you. Which one is method? Which method is suitable for your analysis? Okay. So we find KVL to find the voltage. Okay. We use KCL to find the current. Okay. Number 10 is KVL equation. Okay. This one is KVL. Usually, okay, for basic calculation, usually if it is a single loop, definitely you will use KVL and Ohm's law only. This is Ohm's law, I equal to V over R. Okay, this is KVL. This is KVL. Okay, for more than one loop, you for basic calculation, okay, maybe you can use KVL or KCL. So it depends on the need of the question. Yeah. Okay, this is single loop, right? And the question asks you to find Vx, so definitely you will use KVL. Okay, so we are given a circuit. Find Vx. Vx is the voltage drop across 5 ohm. Voltage drop across 5 ohm. Okay, so how to solve? Just apply KVL in the loop. So let's start with 15 volt. I use the first sign minus 15, and then I find and then this is voltage source. So I just put the voltage source side by side. Okay, so my minus 15 and then plus 2Vx, and then this is resistor. I just add 5, 2 and 1 become 8, multiply with I equal to 0. Okay, and then we have two unknown here, Vs and I. We must solve either one to find the other one parameter. So we know that Vs is equal to 5I, right? Okay, so substitute 5I into Vx in the first equation. So minus 15 plus 2 in the bracket. Vx here is 5I plus AI is equal to 0. And then we can find the current. I is equal to 833.33 milliamp. Please leave your answer in 3 decimal points. Okay, now we want to find Vs. Vs is this. So substitute current into this, and we will get Vx. Any question? Can understand, class? Yes. Okay, this is another example in textbook Alexander Sadiku. Okay, we keep it first. We go to the next example. Yes. Okay, we go to the next example. This is I took from textbook Sadiku, Alexander Sadiku. Find V naught in the circuit and find the power absorbed by the dependent source. Where is the dependent source? Where is the dependent source here? Hidayah? Which one is dependent source, Hidayah? Hidayah, are you with me? Tamarai. Which one is the dependent source here? Write your answer here. Everyone. Which one is dependent source? 2V naught, okay? Okay, 2V naught. The diamond, okay? So, now, okay. Okay, enough. So now we want to find V naught. V naught is the voltage drop across 10 ohm, okay? And then the power absorbed by the dependent side, and now the power here. How to find? Okay, so we should focus on the question. We want to find V naught. How to find V naught? V naught. Since we just learned about KCL, KVL, and Ohm's law. How to find V naught? Of course, by using Ohm's law. V is equal to I R. Okay, we have R here, but we do not have I that flows through this 10 ohm. So we have to find the I. Okay, so how to find the I? This is the step 1. V naught is equal to I multiplied with 10 is, okay, so we name it as the first equation. Okay, so this is, so now how to find the I? Okay, it seems like we can solve I by using KCL. Okay, now we come to KCL. Okay, so this is KCL. Okay, this is KCL. What is the formula of this? What is the formula of this? This is equation of KCL. How about this?
That looks like V equals to IR.
Okay, so it is Ohm's
Law.
Ohm's law. This is Ohm's law. This is KCL. Okay, so that's why I mentioned just now. We must focus to the question, and then we can use any method that is suitable. KCL, KVL, Ohm's law. Okay, and then when you next week and so on. Okay, we will learn about voltage divider rule, current divider rule, Y data transformation, nodal analysis, mesh analysis. You can use any method. Okay, if the question did not mention what method you should use, then you can use any method that is suitable, easiest, okay? And provided that we have information to use the method, okay? So now the first is Ohm's law. How to find V naught? This is Ohm's law. V is equal to I multiplied with 10. Then we have to find the I. How to find the I? This is the KCL. This is a node, okay? So we apply KCL at this node. Current enter is equal to current leave the node. Okay? So now, this I, this small I enter this node. This 25M enter this node, and this is current source, okay? 2V naught is entering this node. So, I plus 25 here, okay, and then plus 2V naught equal to, is there any currents leaving the node? No, so 0, okay? 0 means no current leaving the node. So this is KCL. And then we want to substitute this I into the first equation. So I is equal to minus 25 minus 2V naught. And then we substitute I into the first equation. So V naught is equal to I. Okay, this is I multiplied with 10. And then we get V naught is equal to minus 11 point this. Okay. So far okay? So far okay? Okay. Now how you get minus 21? This minus 21. This minus V naught minus 20 V naught is equal to minus 21 V naught. This is mathematics. Okay. Okay dah sini. This V naught, this is okay. So now we get the answer of V naught. Okay, the next is to find the power of this dependent source. Okay, so the first is to write the formula of power. We have three formula. P is equal to IV, P is equal to V square over R, P is equal to I square R. Which one you should use? Okay, depends on the information that we have. Now, power here, we have the V, this is the current, okay? So we have the information of V naught, yes. And then we have to find the V. If we use V square over R, we have no R here. So we cannot use that formula. If we use formula of I square R, we do not have R as well, okay? So we have to use P is equal to IV. What is I? This is I. So I is equal to 2V naught. What is V? Okay, we do not have V here, but we know that parallel circuit has the same voltage. So the voltage drop across this path is equal to the voltage drop across this 20 amp, and also it is equal to the voltage drop across this. Okay, meaning that the summation of voltage, meaning that V of 10 ohm plus V of 10 ohm here is equal to the voltage drop across this 2V naught, and also equal to the voltage drop across this 20 amp. Okay. So I name the V as V1. V1 is the voltage drop here. It is equal to the voltage drop here, and it is equal to the voltage drop along this path, meaning that V1 here is equal to V of 10, this 10 plus V of this 10 ohm. Okay. So we have V naught, okay? We have to find V1. V1, okay? V1 is equal to V is equal to IR, I in the bracket of R, 10 plus 10, 20, okay? Any question? No question? Okay, so from the first equation here, I is equal to V naught over 10. Okay, V naught over 10. So we have V naught. Just divide with 10, we get 1.19 amps, meaning that 1.19 amps flows through here. Okay. V1 tu adalah, V1 is, okay, power of this diamond is equal to IV, right? Means that I is the current flows through this path. It is 2V naught. Of course, it is 2V naught. Multiplied with the V. V is the voltage drop across this path, across this 2V naught. It is equal to the voltage drop across 25 amp because this is parallel circuit. Okay, this is parallel circuit. Okay, let's say, okay. Okay, another color. Okay, ini apa ni? Purple eh? The purple, the voltage drop across purple is the same as the voltage drop across yellow, and it is equal to the voltage drop across turquoise. Okay? Green. Green. Okay? Why? Because this is parallel circuit. Okay? These three branches are connected at the both end. This end and this end. So this is parallel circuit. So the voltage drop across these three paths is equal to 0. Okay, so we want to find V1. V1 is the voltage drop here. But how to find the V here? Cannot, because no resistor here. And then how about finding V here? Cannot, no resistor here. But we know that the V is equal to this V as well. How to find the V here? I multiply the R. R is 10 plus 10. Okay? So next we get the current. Okay, so now we can find the V1. V1 is equal to 20 multiply with the current I, we get 23.8 volts. So we substitute this V into the equation of power. Okay, so 2 multiply with V0, V0 is here, multiply with V1, this is V1, we get this. Any question? Zafri, okay? Actually, we will learn more on series and parallel circuit next week. Okay? Okay. Apa ni? Okay kaya? Okay. Now please do this example. Obtain V. This is very basic question. Obtain V1 until V3. V1, V2, V3. What is V1? What is V2? What is okay? Which V you want to find first? Which one is easier to find?
V1 first.
V1. You want to find V1, okay? Try to write your equation at the chat box. Okay, any other opinion? Which V is easier to find it first? V3, yes, V3. Okay, why V3? What is V3? The value of V3 is equal to
10 volt.
10 volt because it is parallel with this 10. Okay, so okay, and then the next V3 is equal to 10 volt. Okay, the next V1 or V2?
V2.
V2. We just apply what approach here? KVL, KCL, Ohm's law?
KVL.
KVL in loop, the middle loop kan?
Yeah.
Okay, and then dapat berapa?
22.
Okay, so give me the equation. Let's start with V2. I use the parallel circuit. Minus V2 minus V3 minus 12 equal to 0. V2 is equal to minus 10 minus 12 minus 22 volt. Same as me? Same as mine?
Same.
Okay, now let's try. What method we apply? KVL, KCL, Ohm's law?
KVL.
At the ni kanan kiri, the left loop. Okay, so let's start with V1 minus V1. I use the second sign, minus V1 and then plus V2 plus 24, then equal 0. V1 is equal to V2 is minus 22 plus 24. We get 2 volt, right?
Yes.
Same answer with me?
Yeah,
Same.
Okay, this
We
is
got
very basic.
2 volts.
This is very basic question that will not ask in your final exam and midterm test. Okay, very basic. Okay. Okay, so this is just for fun. Okay. I think that's all for today. Any other question? Actually, this subtopic of Kirchoff law should be taught next week, okay? But I think Ohm's law is quite simple, okay? Because when we solve KVL, KCL question, we will apply Ohm's law as well, okay? No question? If there is no question, we will end our class. But before that, okay, download attendance list. Downloads. Okay, so yes. Any other question before we end our class? $55 only. No question? No, if there is no, then we end our session. No question, right? Okay, yes. Dan ni S1 S2 akan gabung kelas setiap hari Isnin ke? Actually, my plan is this. I want to combine S1 and S2 on Monday afternoon. But I found that there is a student. She is from section 3. She cannot join our online class today because she has other class. Okay, so maybe next week we will change to other slot, not Monday afternoon. Okay, class online, offsite study. Okay, so tomorrow, no online class for section 1 and 2. Okay, no online class for section 1 and 2. You have to watch my video. You have self-study, but I will post your attendance. You have to give your feedback so that it will be recorded as your attendance. Okay, so during our class, okay, so meaning that for section 1, tomorrow at 10 a.m. right? For section 2, tomorrow at 3 p.m. Right? Betul tak? Okay? Okay. So I will post attendance in Microsoft form. You have to answer. You have to give your feedback so that it will be recorded as your attendance. Okay? So for this week, no more online classes. Okay? Any other question?
Beres.
Beres, eh?
Okay.